I am John Robert Hiertos, and I am going to teach about simplifying roots that are imperfect. So, root, so a root will have two parts: the index and and the radical. There's also the radicand and the vinculum sign. But these two are what we're gonna focus. Yes. So if no index is shown, that means that it's going to be a square root. Now, if we take this example, we know that 16 is not a perfect cube, but to simplify it, we first have to take its prime factorization, which is 2 times 2 times 2 times 2. Now, since our index is 3, we need to find 3 of the same number. So here we have 3 2's. So we put them together. And then we will simplify. The 2 3's cancel each other out. So now we have 2 times the cube root of 2. This just stays because there's nothing else to pair it with. So this is our final answer. Let's have another example. Let's take the square root of 48. Now this has a prime factorization of 2 times 2 times 2 times 2 times 3. Now we have 2 2's and then we have 2 other 2's. So put them together. 2 squared times 2 squared times 3. Simplify. The 2 cancels the 2 and the 2 also cancels the other 2. So we get a 2 times a 2 and multiply by the square root of 3. Now we have to multiply these 2 2's, which will become 4 times the square root of 3. That's our final answer. Okay, another example. Let's try the fifth root of 512, which has a prime factorization of 2 times 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 2. Now, of course, these are 9 2's and we need 5. So take 5, which leaves us with 4 2's. We cannot merge them anymore since we need 5, but we only have 4. So, put them together. 2 raised to 5 times 4 more 2's, which would give us 2 times the fifth root of these 4 2's, which we know is 16. And that is our final answer. Okay, let's try something different. what if we have the square root of the square root of 5, the square root of 2 raised to 5. What do we do here? Well, this tells us that there's 5 2's, and since the index is 2, we need 2 2's. So what we can do is split this up to 5. We know that 5 is equal to 2 and another 2 and a 1. So 2 2's, and 1 2 makes 5 2's. So here. And of course we need 2 2's since our index x is 2. So now simplify these both. 2, 2, which gives us 4 raised to 2. So now, what if we have negative numbers? So say the square root of negative 32. Well, we already know that 32 is 5 2's and we need an odd number. Right, so this could become many different things. It could be a negative 2 and just 4 positive 2's, or 3 negative 2's and then 2 positive 2's. And it could also be 2 and just 4 positive 2's, or 3 negative 2's and then 2 positive 2's. And it could also be 5 negative 2's. Now, let's try to solve them all. Now this, we have 2 2's and 2 2's. So, this would give us a 2 times a 2, and then the square root, or negative 2, or 4 raised to the 4 times the square root of negative 2. This, we have 2 negative 2's and 2 positive 2's. So, negative 2 times 2, then the square root of negative 2, which is the remaining 2. So, of course, negative times positive is a positive. So, I get a negative 4 here, and then the square root of negative 2. And lastly here, 5 negative 2's. This and this. And then this is the one left out. Negative 2 times negative 2. And then the square root of negative 2. These two, negative times negative is a positive, so we get positive 4, and then square root of negative 2. So yeah, we have 3 possible answers now. Wait, actually just 2 since these 2 are the same. Okay. Well, anyway, that's the end of our discussion. And thank you for watching.